In this video, we want to prove that the summation of k cubed from k equals to 1 to k equals to n is equal to n times n plus 1 divided by 2 squared. To do this proof, we can use induction. So we can start with the base case here. If you just have n equals to 1, then we know at the left side, it's just going to be 1 cubed. That's going to be 1. And 1 is equal to the right side, which is 1 times 2 divided by 2 squared. And that is equal to 1 squared equals to 1. So this works. And now the inductive step is that we can assume it holds for n, and we need to show it holds for n plus 1. So we can write down n plus 1, k equals to 1. So the summation of k cubed from k equals to 1 to k equals to n plus 1. We want to prove that this will equal to n plus 1 times n plus 2 divided by 2 squared. And the left side will equal to, by the inductive hypothesis, this will equal to k equals to 1 to n of k cubed plus n plus 1 cubed. This will equal to n times n plus 1 divided by 2, and then the whole thing squared plus n plus 1 squared plus n plus 1 cubed. So you can factor out the n plus 1 squared to get n plus 1 squared times n squared over 4 plus n plus 1. This thing will equal to n plus 1 squared times n squared plus 4n plus 4 divided by 4. And then notice that n squared plus 4n plus 4 equals to n plus 2 squared. So this will equal to n plus 1 times n plus 2 divided by 2 squared. So this will mean that since the induction is proved, you'll have the sum of cubes from 1 cubed plus 2 cubed all the way to plus n cubed would equal to 1 plus 2 plus all the way to plus n squared. The sum of the cubes equals to the square of the sum. And that is how you prove this problem.